Okay, so we talked about what a Wireshark is, right? Packet sniffer. You can download it and install it on your laptop or your home computer. It doesn't come with the operating system, so if you're using computer outside of the classroom, we need to make sure that the application is there. So if you're using home computer, download and install. You can search for Wireshark through Google and find the download, or you can click the link that I provide here. So let's open up our Wireshark. You can search for Wireshark on your Windows search bar. And then you will find the application and you're going to click it. Now, when you install the application, it's going to tell you that you are required to install npcap file. That allows your system to access the network interface card and make it available to listen or receive signal that's being passed through it. You should see your adapters list, right? Earlier, I couldn't get a whole list of adapter on my desktop because I didn't have the privilege to do that, right? So I have to talk to TSS to fix that problem. So mine is a little bit different than yours in that you are using a desktop. So what we're going to do is we are going to find, I'm going to use my Wi-Fi and you are going to use your Ethernet connection. It might be live. It will be, your Ethernet 8. It will be your Ethernet 8, right? Only if you see the wiggly line and it's an Ethernet number like Ethernet 8 or Ethernet 9, that's the one. Because my laptop does have a network adapter, like it just has a Wi-Fi adapter. I'm only going to use the Wi-Fi. See how you don't see that on my list? So you're going to use the adapter that's available to your system, and then you're going to select it by clicking it. Okay. And if you double click it, it's just going to run. Now, if you single click it, you have to click the start or the blue fin button at the top left. Okay. Now, while this is running, what you're going to do is you are going to generate a traffic. So open up your browser. And you are going to visit this website. There are not a lot of really many HTTP website left, right? So I'm going to go ahead and copy this URL. And then I'm going to go to my browser. And I'm going to paste it. What does this do? It's going to create traffic, right? So as you can see, there are many different systems communicating, right? When you're looking at your Wireshark, you're going to see all of these systems talking, right? You see a lot of UDP. There's some web activity. You see that? TLS version 1. And ultimately, we did generate some kind of HTTP traffic. And sometime I normally refresh the page a couple of times also just to make sure that traffics get recorded. And you gotta give it time to relay that information to the monitor. Okay, so we can leave that page open. And then we want to wait a few minutes for our capture, right? So once that time is up, you're going to click the stop red button at the top. Now, while we wait, let's talk about some of the color code. Now, you might have color code that doesn't fall into this table. I pulled this from Wireshark website a while ago. But, you know, some of the general color might help you. So you're going to get light blue for UDP, that's user data frame protocol. Those are the packets that, you know, open as they arrive, right? Often used for sound, video. If you're streaming like iHeartRadio or online podcast, likely it's used in UDP. If you're watching YouTube video, it's going to use UDP. Now, TCP is going to be in the light purple, is more stable and secure, but it takes a little bit longer to deliver. So you do see TCP packets, so you're going to have a mix of both. You're going to have black. Black packets are packets that are questionable or sometimes they have errors. You might see some of those. And then you have light green, which is more rare now compared. So whatever the traffic that we generated by visiting that HTTP website, it's going to show up in green or light green. And then light yellow is what you see. We talked about SMB. So if you want to look at that traffic, you would see SMB traffic, right? And then, you would get dark yellow for routing. So you might see a lot of Cisco devices. And then for your dark gray, those are, remember we talked about SYN flood and all of that for denial of service. So SYN for TCP, SYN and acknowledgement traffic, you would see that in dark gray. Okay, so let's stop our capture now. Go back to your blue fin icon on your desktop. And then we're going to hit the stop button at the top. Click the red button to pause it. Now, if for some reason you accidentally close this, you got to redo those steps, right? Start your capture, open your website, refresh it a couple of times, let it record for a few minutes. So what we did here was we capture all the traffic on the network that we're attached to. So on my side, I'm connected to the wireless side of the college. And you might be too, because the Alienware can do that. But your desktop might be connecting through the local area network. So if you selected Ethernet, that means that you're connecting through the wired network, right? And the cool thing about this is you're going to have tab access. So it allows you to organize based on, you can say the time or the length of the packet or the information. And so, or even the protocol. If we're looking for a certain type of protocol, you can sort it a certain way. So let's look at the lab, and it tells you that after we capture, right, and I give you some detail on what that is, source, where that's sending from, right, destination, where that's going to. Think of a packet is like a piece of mail or a package that you're supposed to go from your home to your friend's house, right? So you have a source, from, destination, to, right? And then the protocol that's used. So all of that is organized in the tab. And then you also have the length. This allows you to look at the length of the packet in bytes. So just think of it like a size of it, right? How big or small is it? And then the information and the details. So what we'll do is we are going to come back to our scan, and we're going to go all the way back up. Now, your first packet might be different than my first packet. Remember that we're on two separate segments of the network, and also even capture in time. Sometime it records that. You see, I have some black ones right there, right? So your first packet might be different than mine, but let's open up the first packet. So my first packet, as you can see, is the TLS right here. We're going to open that up. Okay. And what we see is we would see what kind of traffic is the first packet. So how can I describe this, right? When I open up the packet, this window pops up. Okay. And if you look at the information that's given in the tab itself, I know that this packet, right, it's coming from this source, it's going to this destination, and the protocol that's used is here, okay? So you can describe like the type of packet. If it's a UDP packet, look at the protocol. And you can also expand. You see this top window when it pop up that window for the packet information. You can also expand, and it's going to give you some information about the frame, if it's using frame, right? And since this is a Cisco device, or it's going to a Cisco device, right? it's saying that this is a Cisco device going to a Cisco device. It's gonna give you the information about it. So it's Cisco normally is included into the vendor information is included into the address for the Cisco devices. That's what you see. And yours might be slightly different again. Okay. So with the information you have for the first packet, you view it. And then you can tell me what kind of traffic is it. Is it a UDP packet? Is it a TLS packet? Is it an HTTP packet? And then what we're going to do is we are going to go back. We can close out that packet details information, go back to our capture. We're going to click on the protocol tab. Click it. And when you do that, you are sorting your protocol, because remember, they're all mixed up, right? It's tracked based on when it was generated. So when you click the protocol, you're going to sort it. Okay? And then once you sort it, you're going to locate the HTTP packet in green. Okay, remember it's light green, right? Now, if you don't have it, you're gonna probably have to regenerate the traffic again. But you should, because you already, open up the website. So what we can do is we can also filter. Here's my filter field, right? You can look for HTTP like that. That's quick. And then press enter. So put into your filter field at the top, just type HTTP. And if you generate it, it should be there. Okay? Because I always get like, oh, I don't know why it's not there. Well, maybe because you capture it after or before you open the website and close the website. So it should, you just gotta let it wait. So here's my traffic, right? And I know that it is this one because that's the website that we had visited, the Fabricon. Okay, so in the HTTP process, we would see that there is a get process, okay, where it's coming from, where it's going to, and the response back. So once everything is good and served, the web page is provided to the client request, you're gonna get a 200 code, which is okay. So from a back end, when we receive a 200, it is a code for us, a 3-digit code for us to say that, oh, everything is good from the web server to the client request. All right, we're good. Okay, so how many packets were captured? So if I filter this out, I just count each line is 1. 1, 2, 3, 4, 5. So I have 5 here. You might have more or less. You might have 2, right? You might have 3. So count up the lines, and each entry is going to consider 1 packet. And then you're going to click on the HTTP packet to view the information on the lower pane. And then you're going to click the arrow next to Ethernet to expand it. Okay, so I'm going to choose the first one. I'm going to click it once. Okay. And then on the bottom, the bottom pane, I'm going to expand Ethernet arrow. Click the arrow next to Ethernet 2. And if you want, you can expand the arrow underneath that, right? So it tells me the destination and the source, where it's coming from and where it's going to. Okay, so we can put down, and you can copy and paste it if it's too long for you to type, right? So I would see right here is my destination. This is the address. and here's my source. And then if you want more of, so you said, why is it like that, Dr. Nguyen? Why is it like letters and numbers, and why is it IP addresses up here? From a network standpoint, you're gonna get the IP addresses here, but the destination and the address here, when we're clicking Ethernet 2, you would see that as MAC. Okay. So MAC addresses for appliances, you're gonna have vendor name, and then you're gonna get the letter and the numbers. These are the MAC addresses. Now, if you want the IP addresses, it would be at the top. You would see that listed at the top pane. So you can type the IP addresses as the question asks you that. And on the lower pane, what is the source port and what is the destination port? So in general, you should have some kind of port. If you don't have it, that's okay. But you need to click on the right thing, because a lot of my students are like, I don't see it, right? If it is UDP that you click, you're not gonna, it doesn't have TCP. Okay, so if it's a TCP, so sometime depending on the packet. But we're looking at HTTP, so it is a TCP protocol. Okay, so on here, we're going to click TCP, Transmission Control Protocol. That's the middle arrow in the middle here. And you're going to see the port. Of course, it's port 80 because it's HTTP, right? So what I'm teaching you here is not just look for an HTTP packet. In the future, you're going to look at many different packets, but each packet, you can find all of that information. The IP address is in the internet protocol, the transmission control protocol, if it is a TCP protocol. It's also have a source port, a destination port, which port is coming from. Remember, port is like Windows and door, which port it's going to, right? And the sequence number and acknowledgement. So sequences number is like this. When you sending data, it's gonna come in a group of packets, right? It's kind of like I'm sending you a car, but in parts, okay? And when you receive all the parts, there's number for you to put your car back together in one piece, okay? So data is being sent as many packets across, because your video could be like 3 meg, right? Or even bigger. You think that it's going to be a 3 meg packet? No, right? We're going to have packets that are smaller, so it's chunking it up and it's sending it in chunks. So when it gets to the destination, TCP is going to acknowledge. It's kind of like you signing off on your packages. When you receive them, the sequence number is going to be able to put everything back together and say, oh, here, everything is now intact. Here's your data in the presentation layer. Okay? So all of this is relevant for us in the communication. And then it says next sequence number. There's your next sequence number. That's the relative sequence number. It's kind of like I receive a steering wheel, and the next thing I receive the wheel for the car, right? So it's going to reference what's coming next, right? And the acknowledgement for the raw, and then you have the header length and all of that, right? So a good attacker, they really study what's in the packet and how they can dissect the packet and modify the packet, right? So therefore, if you're a really good protector, you need to do the same thing. You need to understand what a packet looks like, what's in the packet, and what's in the header of your packet. So the header is kind of like the label on your package of your mail. It's going to say where it's going to, where it's coming from, how big or heavy is your package, right? And so on. Okay. So as you click on the transmission control protocol arrow, you're going to see the source port, the destination port, and the payload size. That's your data size. Okay. Now, in the case if you're studying malware in network traffic, payload size is important because malware tend to have larger payloads when it comes through the network. Okay. So pay attention to that. And then still in the transmission control protocol, you're also gonna see the timestamp of the packet. Okay, so I'm in transmission control protocol. And if I scroll down, I should see timestamp and I expand it. And it tells me that this is how fast the frame is. So it's like 0.34 of a second for it to stream. And it's very quick. Okay. But, you know, timestamp in the packet, it's really the window on how that packet is streamed or sent. The way we think of timestamp is like when it's arriving and when it's coming, no, right? It's really the frame on how it's sent in stream. Okay. Any question? All right. So then we're going to go to step 13. We're going to expand the hypertext transfer protocol and we're going to review the information. Remember that we're evaluating an HTTP and you can shrink everything back up or you can just keep expanding. So the last one on the list, you're going to expand it and scroll up or scroll down so it moves up. And so here, right, I expand it and I would see the host. This is my web server host name, right? Remember we type in that URL. So we would see that here. Then connection is to keep it alive. So it's always going to be open to that page. It is an upgrade in secure request. And the user agent is the browser that it supports. So you would see Mozilla, you know, you would see. So this is part of the development for that particular page and web server. And then the encoding the language. So this pertains more to the web services. Okay, that's the HTTP. And so it says what does the timestamp, what is the timestamp of the packet? Does the packet contain HTTP request or HTTP response? So when we click on this, right, yeah, it was from the timestamp is from the TCP and you do see some payload, but you would see if it is, so this is a request. The packet I'm looking at is the request. But the packet you're looking at, right, it also says request on the bottom. But if you're the packet you're looking at, it might be a response. So it depends on which packet you select. So here, when you're looking at a GET, that's usually a request. But if you want to look at a response, like for example, look at that one where it says 200 OK, right? That's a response from the server. That's a reply from the server. Okay. And then we would double click the packet to view the packet information, the connection, what type of connection is shown on the packet. So coming back here, I can double click. So you can view it in pane like this, or you can double click where it expands. Okay. And then we would say connection is shown on the packet, the user agent on the packet. We already talked about the user agent in the last one, but if you want to see the user agent, go down to HTTP. It should tell you the browser support for the user agent. And then the connection is keep alive. So that's under the HTTP section of your. Now, some website, it doesn't keep it alive, right? It will just open and close. That won't be a keep alive type of connection. Understand? That means that it just like serve and then it ends. But when most website is keep alive because you, like I open a Google page, as long as I don't close it, it's still going to be open, right? That's a keep alive. It serves that page and it's gonna stay open, so that's a keep alive. Okay. Are we good there? Any question? So we can close the packet detail information. Then what we're going to do is we are going to keep that same packet. We're going to analyze and we're going to look at the SYN and the ACK and the SYN-ACK type of communication. So I'm going to close this. Going back to my Wireshark capture, still keeping that first option selected, that first packet entry selected. I'm going to go to the top bar of my application. I'm going to click Analyze. Okay. And the step tells you that once you click Analyze, you're going to select Follow and click HTTP Stream. So here, we're going to go click Analyze. We're going to click on Follow. And then if it's an HTTP, it's going to give you HTTP Stream. If you don't see that, you're selecting the wrong packet. Okay? So it has according, if you're using UDP, it's gonna highlight, it's gonna see how it's grayed out because it's not UDP, right? If it is, then it's gonna be in black and you should be able to select it. So I'm gonna select HTTP stream. And what does this do? It actually shows you the conversation between the system, right, back and forth on what's requested, who that's going to. This is really good when you're looking at communication, like, how does the attack happen? How does the malware gets into your network? You follow that conversation between the systems and you would get a clearer picture of how it's communicated. Okay? So when we follow the stream for this particular packet, we would look at how many SYN and ACK and all of that. So here, it opens this up, but look, it changes your display, okay? It organizes it. So go back to your application. It's going to show you this is a SYN, this is a SYN ACK, this is an ACK. ACK stands for acknowledgement, AKC. SYN, SYN, is for synchronization. So, and then the fin ACK is the finish, right? The final package acknowledgement. So you would count them up, right? So when you do a follow stream, it's gonna filter out only the conversation between the system and it for the HTTP here, and it's gonna give you that. And I do get some error, you see? Or questionable packets. Okay, so count those up and write down your answer. And then you can clear your filter because we just filtered. And then we would do the same thing but we're going to look at the statistic for UDP. So next we're going to clear the filter on the Wireshark. So let me move my zoom bar. We're going to click the X on the right hand side here. Look, right? Small X, red. Clear that. And we're back to our old capture look, I should say. And what we're going to do is we're going to select statistic at the top and we're going to select UDP multicast stream. So multicast means that it sends to a group of devices, right? And so that means that it has a group of target that's multicast. And what we're going to do is we're going to look at if there are any kind of streams for the UDP. So at the top, select statistics, go down to UDP multicast stream, select that. Okay. So scroll down and you should see some kind of count at the bottom. Here. I know it's kind of hard to see on projection, but scroll all the way down. Yeah, I don't expect you to sit there and count all of them up, right? The whole point in statistic is to be able to get that. So it's gonna give you some statistic information there. Normally these also have counter too, so depending on the screen that you are selecting, and then you can also apply the filter, so you can filter within the filter, right? Filter from here for these. And if we need to save or copy information, it gives you that functionality right here. So we will close the window after that. And then what we'll do is we will look at the endpoints. So endpoints are the systems that are connected to the network. Like your computer is an endpoint, your tablet or laptop is an endpoint, right? There's no additional system connecting to it, right? Therefore, it's called an endpoint. So I'm gonna go ahead and close this window now. Coming back to my capture, I'm gonna hit statistic and I'm gonna find endpoints. And it sums it up for you, or it gives you the summary for it, right? And, you can also select some of the options here to kind of filter out, but it tells you like which system have the most packets, or the count of packets that you would have. So, and then if you look at the tab, it does the count for you. How many IP version 4 was sent, and so on. So you will be able to see how many endpoint system are shown, and then you're going to click on TCP tab to look at TCP packets that were transmitted. Now, why is that important in ethical hacking or pen testing? Well, we talked about the traffic and studying the traffic. You wanted to see the type of services and the communication across the system. Ultimately, you want to see a better picture of who's talking, what systems use, what systems communicating. So when I selected endpoints, this is what it gives me, right? If you count them up for mine, it tells me right here, there's none on the tab. So if I click TCP, that means that there are 97, you see the number at the tab, 97 TCP packets that were sent when I capture the traffic. And then the accordance port, right? We see 443, that's HTTPS and the other ports. So once we click TCP, we see that, and then you can also click port tab. So, oh. Inside TCP, if you click the port tab inside TCP, okay? If you're trying to find it up here, it's not up here. In TCP, you click port, and that allows you to sort the port of TCP. And port 80, because HTTP is under TCP, it's there, right? So if this is kind of new to you because you don't know much about networking, I encourage you to take CIS40A or learn about networking. That's going to really help you because in this field, if you the stronger you are in networking, the better you're off with security. So I would have only see one that has port 80. So in TCP tab, if you click port 80, it shows there. And then close the endpoint, take a screenshot, but we have to select statistic and the graph. So I want to show you how you can visualize it. So we're gonna close this window, come back to our capture, go to statistic, and we're gonna do IO graphs. And IO is input output, right? So it gives you the overall graph. You can choose how your graph would look like by configuring it, but by default it looks like this. So for like report purposes or analysis purposes, this might be of importance. So if you have like a flood, like remember we talked about SYN flood or TCP flood, right? And we want to put that into visualization. You capture that traffic, right? You filter out that traffic, and then you can have it graph, or you can graph the capture. Okay. Any question? Okay, so we click the close button to close the graph, and then we're gonna look at the conversation. And the conversation we're interested is going to be the UDP conversation between the, if there's any kind of DNS conversation, right? So we're gonna close this. We're gonna come back to our capture, and we are going to use statistic and conversation. And then we're gonna click on UDP. So on mine, I have 122 right there. On the tab, it shows you the number. And right away, I see 5353. You know that DNS uses UDP. So port 53 belongs to DNS. And so this is normal. You would see that whenever you have web domain that would be tied to DNS, and so you do have resolution for DP with DNS and also web. So you would see a lot of port 53 popping up, and that's normal for a network capture. So we would click on the UDP tab, and then within that tab, right? Within that tab, you would click the port B right here, which is this column. So I click on UDP here, and then right beneath it, you should see port B. You're going to click that. That allows you to sort, right? The destination port, like the receiving port that is just 53 to start, but you see all the other ports down at the later group. So we should be able to see 53. And then we can close that window, or we can come back to statistic, and we're going to look at the IP addresses statistic and the protocol type. So you would see certain IP addresses uses certain services and protocol. So we would come back here. We can close this window, come back to our capture. I'm going to close this other one. Okay. Go to statistic. And then we're going to select the IP version 4 statistic, which is on the bottom, and then IP protocol types. So it kind of gives you the count for the UDP and the TCP. Remember that sniffing is about studying and gathering information so we can understand better about the network, right? And then your percentage. So this can be useful for performance and maintenance for network as well. So for version 4 of IP addresses, it shows that there. And then you would also do the same thing for, oh yeah, we have that information. And then we will come back and we would look at DNS details, right? We talked about DNS today and how are we going to be able to identify that. So statistic, and then we're going to choose DNS. And in the window, it's going to give you the information about the total packets for the DNS. On mine, it counted 126. And all the details, the query, the response count, the classes, statistic for the DNS information. Any question? So that kind of give you a little basics in Wireshark exercise, right? I encourage you to use it more and learn more about the other tabs, the other functionality, and how to understand the information better. Okay, so when we're done, right, you can save this capture as a, but you have to open it up in a network sniffer or a Wireshark application. But I'm not gonna save it. However, if you want to save it, you can. So when you close, you can, or go file save as, and you can save it to a location that you want, right? So when you're investigating or when you're doing pen testing or when you are, trying to capture, you want to save the file for later reference. So you can go back and open it up and then, evaluate it some more. So we'll close this without saving. Okay, now we're gonna stop share from here and I'm gonna switch PC because I have the virtual machine over here. So we are gonna work on part B, C, and D. It's fairly fast. So we have about close to an hour, like 50 minutes. So for B, we're gonna need a virtual machine, a Kali virtual machine. So just like last week, you are going to visit the website. We're gonna download the regular virtual machine for VirtualBox, which is this one. Do not use the weekly one, right? Use this one. And then we are going to extract it. So once that's downloaded, and that normally takes about 7-10 minutes when it's busy, we're gonna find it in the downloads folder, right click, share more options, 7-zip, and extract files. Again, if you're doing this outside of here, make sure that you have VirtualBox app and 7-zip to extract. Yes, you can use WinRAR and other application, but it's probably ideal to use 7-zip, right? Because it is zip using 7-zip. So once I extract it, it's gonna give me the regular folder like this without the 7-zip symbol or the zip symbol. I want to open that up, open up the subfolder, and I'm gonna load the Kali virtual machine into the player by double clicking the blue file. Bye. Now, once you get it here, you can go ahead and click start. Okay, so if you have an error, that's because you're playing from a file that's still compressed, so you need to go back extract or find the extracted folder and open up your file, but you need to remove it from the list first. Call me if you need help in that area. So once our virtual machine is loaded, and I put the link here for you in case you need to download for your VirtualBox in 7-zip. Always start your Kali VM with an update. You don't know how important this is because your application will not install or run appropriately. And I suspect that last night, some of the virtual machine did not function correctly, maybe because the update did not push all the way. The student might have ran the command, but maybe some of the packages did not download accordingly. So it's always good to periodically update it whenever you start using it. Start it with the update. Even if you have the latest version, okay? Because open source tools always change. We're gonna log in using KALI and KALI for passwords. So I just finished part B by loading virtual machine. Download, extract, and load Kali virtual machine. So what we want is, you said, okay, well, I know how to run Wireshark on Windows environment. We want to run Wireshark in Kali virtual machine environment. How do we do that, right? Remember that when you're running Network Sniffer, you need to be at a higher privilege than a regular user. In Windows environment, I can run it as a regular user, but in Linux, like Debian Linux, you need to have sudo to reconfigure the package for Wireshark, even when Wireshark is already installed. So coming back to Kali here, it's already loaded. I'm going to push update. So open up your terminal by clicking the black icon right there. Let me zoom in. And I'm going to do a sudo apt update. Can you do an apt-get update? Yeah, apt-get works for Ubuntu and it will work for this the same, but in Debian, you just need to do an apt update. Okay, so that's going to take a few minutes to update. And then after we put in our Kali password, right, that's going to push, it's going to download updates. And yes, you can copy and paste the command if you don't want to type it. So we're going to do sudo super user do dpkg reconfigure Wireshark comment. Now, before I had a typo here, that should be Kali. Allow Kali user to perform scan. So this, when you run this, that would allow a user like Kali, as who you log in, to be able to scan. Because Wireshark is in Linux, right? Because it's listening to signal at the low level. It's not intended for the user. So we're gonna run that. And then you're gonna see the configuration window is gonna pop up. And then you're gonna go ahead and press enter. Sorry, I'm gonna tab, hit tab, and then press enter, and then enter. That's it. So hit tab to select, and then press enter and enter. Okay. I should note that. All right, so once we press enter, that now allows Kali, the user, Kali, to be able to perform scans. So now we're going to do IP address, right? this just allows us to find the system IP address. So the version 4 IP address is located here. So that's your 10.0.2.15. I already noted that for you. And the loopback address, which is the 127.0.0.1. So once we have that IP address that we need, because we're gonna scan ourselves, right? Or you can also determine your target and find the IP address for your target. Kali Linux have Wireshark installed, so you don't have to install it. But if you're using other version of Linux, right, you can check. The way that you can check, I'm going to show you. You can say which, and then the application. If the application exists using the which command, it's going to tell you where that is as a directory. If it says it doesn't exist, or it's not able to find it, then you have to install. Okay, so we know that Wireshark is installed, and you can check it using which command. And then what you do is you call up the application by typing its name. And we got the UI, right? So here, what it's gonna do is gonna give me, just like what you saw earlier, my adapters. But remember, we're using a virtual machine, so it's referring to the virtual machine adapters. So everything is gonna be F0. We're gonna click on the F0, which is Ethernet, the first Ethernet adapter that it sees, and then we're gonna capture. So I just want you to know that because we're using a virtual machine that requiring RAM and the application use RAM, there is going to be lag and your graphic is not the best, okay? So be patient with it. So we're gonna select this, we can double click or we select it and click the fin. Okay. And if you want, the next step is we have to generate the traffic. So we can minimize this, open up a browser, Firefox, inside our virtual machine. And then you're gonna visit the same website that you did in the earlier parts. Okay. And then we're gonna also visit Wireshark website. So we can leave that tab open up another tab, paste and go. Okay. So you have to generate traffic for it to give you traffic records, right? Because if you just open up Wireshark in a virtual machine and just let it sit there, nothing's gonna happen because you have to give it traffic. So the more website you open, the more traffic it's gonna capture. Or if you have communication with another system that's connecting to your virtual machine, then it's gonna have traffic. Unlike what we saw earlier on a regular host PC, what will happen is with the host PC, because it's connected and there's, we still have to generate traffic for it, but it sends all the activity, communication activity around it, right? All right, so and the tab that you reduce, it's going to be here. So the blue, see, now we have activity. We have things that are happening. See that? And then, you can open up other websites. So you see that there. Okay. So we're going to stop it now. And then I want you to filter based on IP address. So you can copy and paste this into your filter field. And if you're not sure, you can just type. And what it'll do is it's going to give you the preference list from the application, and then you can just edit that, right? So we want IP.ADDR, oops, and it's a double equal, right? And then you want to put in your IP address 10.0.2.15. That's our actual virtual machine address. And if everything looks good, it's gonna be green. If not, it's gonna be red, and you have to check your typing. And so what we're looking for is we're looking for any kind of packets that contain our IP address of our virtual machine. So it could be from or to, right? So you see some for source and then some for destination. I want you to take a screenshot of that. And then just like what we saw earlier, we're going to go to statistic and we're going to go to DNS. Where was that? There it is. Oop. And then I think I have you selected the general. You can just do the general. So once you selected the general, because you see the version that you're using on Kali is slightly different than the version that you were using earlier, right? So still the same functionality. So if you select the general, you're gonna see your packet information for DNS. So how many packets total? It does the count here. I have 168. Yours might be a little different. And then the service statistic, you can go down. Let me see. Yeah, service stat, I got 0. And then the average maximum payload size. So did it say that? Yeah, you scroll down and your payload size is like after query name. So for mine, my average is about 80.60. Look at yours. And then my min is 28 and my max is 282. And then I can save it, right? So we can close this, file, save as, and then we can call this scan1. And remember that this is going to be in the home directory under that user Kali. Okay, last part, part D, and then we'll be done. So I want you to see the difference between Wireshark and we're going to use NetDiscover, right? And NetDiscover is in Kali current version. But don't rely on that, right? You can go to Kali website to check what's still there or not. They do remove applications that is not supported, you know, things like that. So down the line, if NetDiscover goes away, it's because maybe it doesn't work with it anymore. So what we'll do is we will come back to Kali here. We can now close our Wireshark, right? We'll go back to the terminal, and what we'll do is we will open up NetDiscover -H or option H. And if you see it in change in font for Kali, it's there. And you can always say which NetDiscover to see if it's installed, right? And then you see all the options. So it asks you here, it says, what type of result can be displayed using the option I? So when we look at option I, we have to scroll up maybe. Option I, we can use option I for network devices. We can use option R if you scroll down, right? That is going to be for range. And that we can scan a range of IP addresses using a CIDR, like a /8, 16, a /24, so on, right? So we would put an IP address and then a slash. That will give us the subnet mask value. So 24/16 or /8. So that is a range, is the R. And then option P. So the lowercase p is for passive mode. Only sniff, right? Remember we talked about passive and active earlier? So NetDiscover allows you to have 2, The passive mode is only sniffing out, right? If you don't do a passive mode, then it becomes an active mode. Then it would also add traffic to the scan, right? So you see that this tool is useful if we're doing recon. And then we would do an option L, and this is a lowercase L. So if we look for lowercase L, that's a file. So what we can do is we can scan the list of ranges. So I can have a text file, right? Like let's say ip.txt, and I can do an option L, ip.txt. And on that text file, I would have 100 IP addresses that I want to use for scan, right? Or not 100 ranges. So that I can, Linux is great for automation that way. It has a lot of functionality in how we can automate it with text files or CSV and so on. Okay. All right. So what we're gonna do is we're gonna try it with our own range, and this might take a little bit of time, right? So I want you to know how to do a range. So we're gonna do a range of our IP address, and the subnet mask is 255.255.255.0. It is a slider 24. So we can copy this and you can paste that into the command, or you can type. So what I'm telling it is, I'm telling it to scan, right, using the option I. We learned that is a device, right, or an interface, Ethernet interface for the range with starting with this IP address, right? So we're gonna scan the entire segment using our Ethernet adapter, okay? And so there we have it. So it's gonna go 2, 3, 4, and it gives you some information there. Okay. So it tells you 3 captured ARP packets and then 80 captured ARP packets. Now, Linux tools are not gonna be like what you see with Wireshark, right? You're gonna see that it's gonna give you minimal and mostly text. That's okay. We just need the information we need. Now, if it asks you for the password, you type that in. Screenshot, what type of information is being displayed? Well, your scan results, right? Did we do a passive scan? No, right? So it's giving you the IP address, the MAC address, which is an ARP table, the count, the length, and so on. So your ARP packets information was produced. And now we're going to try a passive to see if there's difference. And we're going to scan everything around it. So Control C. So Control C to get out of that or open up another terminal, right? And then we're going to paste the selection. So I ran the command here. That means that I'm going to run NetDiscover using my Ethernet adapter, and I'm going to do a passive mode. And it tells you passive at the top. Okay. We can maybe open up some pages. See if it does. You got to make traffic. But it doesn't have anything because there's no host connecting to it. So that's fine like this. So I want you to know how to use it. So take a screenshot. Oh, wait. That one, yeah. Take a screenshot. How many entries for the output? If you have none, put none. Okay. We might have to have direct connection for it to see. So it tells you 0 captured. See? But if you have another system connecting to it, it will probably resolve and give you information. Okay. And then save your screenshot, put it on your lab. Now, if you want to get out, right, Control C to, I need to put that. So yeah, I did press Control C to return to the terminal. And then when we shut down, make sure you're nice to your virtual machine. Shut down now to close it off. And make sure we save our document, right? And then submit. I will stop recording.